Hello, in this lecture we'll find out the length of line segment X. In the drawing we have triangle ABC. We know that side AB is equal to side AE. We also know that side BD equals to 3 units, side DE equals to 7 units, and we also know that angle BAD is equal to theta, and angle EAC is also equal to theta, and angle BAC, this angle is equal to 90 degrees, and we want to find out the value of line segment EC that equals to X. So we want to find out the value of X. Okay? So first of all, we will define angle DAE. This angle is alpha. And from point A, we draw perpendicular to BC. Okay, so here this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees, and we will define the touching point of the perpendicular from point A to BC as M. And then we will calculate the ratio between the area of triangle ABE and triangle ADE. So actually we'll calculate the area of triangle ABD, this triangle, here the squared brackets is the sign for the area. It means the area of triangle ABE over the area of triangle ADE. So what is the area of triangle ABD, this triangle? It will be equal to the base of the triangle, that is BD, times the height to the base, that is actually AM. AM is the height to the base BD because of the fact that AM is perpendicular to the base BD. Okay, all divided by 2. So the area of triangle ABD is equal to the base of the triangle, that is BD, times the height to the base, that is AM, over 2. Then we divide it by the area of triangle ADE, and the area of triangle ADE, this triangle will be equal to the base of the triangle, that is actually DE, times the height to the base. AM is the height to the base DE because of the fact that it creates 90 degrees with the base DE. So the height is AM over 2. We'll repeat again. The area of triangle ADE equals to the base of the triangle, that is DE, times the height to the base, that is AM, over 2. Here we have 2 in the numerator and 2 in the denominator, so 2 will get cancelled, and what is left from this expression after we cancel 2, what is left, it is actually BD times AM over DE times AM. We have AM in the numerator and AM in the denominator, so AM will get cancelled. And we left only with BD over DE. BD equals to 3 units, and DE equals to 7 units. So in conclusion, we found out that the area of triangle ABD over the area of triangle ADE equals to 3 over 7. In the next step, we will calculate the areas of triangles ABD and triangle ADE in a different way. Here, we will take the base of triangle ABD as side AB. So side AB is the base of the triangle times the height to the base. The height to the base must create 90 degrees with the base AB. So from point D, we will draw perpendicular to AB. So this angle equals to 90 degrees, and this angle also equals to 90 degrees. And we will define the touching point of the perpendicular from point D to AB as point O. And because of the fact that line segment DO is perpendicular to AB, actually line segment DO is the height to the base AB. So we will define line segment DO as edge 1, that is actually the height to the base. Okay, so the height to the base is edge 1 divided by 2, that is the area of triangle ABD, the base AB times the height to the base, that is edge 1 over 2. Likewise, we'll calculate the area of triangle ADE. Here the area of triangle ADE will be equal. Now we will take the base of the triangle ADE as side AE, so it is AE is the base of triangle ADE times the height to the base. Here the height to the base must create 90 degrees with the base AE, so from point D we will draw perpendicular to AE. So this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees, and we will define the touching point of the perpendicular from point D to AE as point K. So AK is the height to the base AE, so we will define AK as edge 2. So the height to the base AE is edge 2. Again, it is the height, the base AE times the height to the base, that is edge 2 over 2. Again, the area of triangle ADE equals to the base AE times the height to the base, that is edge 2 over 2. So here we have 2 in the numerator and 2 in the denominator, so 2 over 2 is 1, so it will get cancelled. What is left after we cancel 2? What is left, it is actually AB times edge 1 over AE times edge 2. Because of the fact that it is given us the question that AB is equal to AE, therefore AB over AE will be 1. So AB over AE will get cancelled. So we left only with edge 1 over edge 2. In the next step, we will calculate the values of edge 1 and edge 2. What is the value of edge 1? Here we will focus on the right triangle, triangle ADO. In the right triangle, triangle ADO, this right triangle, we know that sinus theta is equal to H1 over AD. I repeat again, in the right triangle ADO, you know that sinus theta equals to H1 over AD. We will multiply this equation by AD, and we'll get that H1 equals to AD times sinus theta. So here we can write down that H1 is equal to AD times sinus theta over H2. We'll calculate the value of H2. We'll focus on the right triangle ADK. In the right triangle ADK, we know that sinus alpha equals to H2 over AD. Sinus alpha is equal to H2 over AD. Here we will multiply the equation by AD. I repeat again, in the right triangle ADK, sinus alpha equals to H2 over AD. We will multiply this equation by AD, and we will get that H2 is equal to AD times sinus alpha. So we found out that H2 equals to AD times sinus alpha. I write it down. H2 is equal to AD times sinus alpha. Here we have AD in the numerator and AD in the denominator, so AD will get cancelled. And here, according to equation number 1, in conclusion, we got that 3 over 7 is equal to sinus theta over sinus alpha. So here we will cross multiply this equation number 1. And we'll get that according to equation number 1, 3 times sinus alpha equals to 7 times sinus theta. So we'll find out the value of alpha. Here, from the drawing, we can see that 90 degrees angle BAC equals to 90 degrees from one side, But from the other side, angle BAC equals to theta plus alpha plus theta. That is to say, angle BAC equals to 2 theta plus alpha. Angle BAC from the other side equals to 2 theta plus alpha. So from this equation, 2 theta plus alpha equals to angle BAC equals to 90 degrees. We will conclude that 2 theta plus alpha equals to 90 degrees. We will subtract 2 theta from this equation, and we will get that angle alpha equals to 90 degrees minus 2 theta. Okay, angle alpha equals to 90 degrees minus 2 theta. Now we can substitute angle alpha in equation number 1 by 90 degrees minus 2 theta. So we'll do it now, and we will get that according to equation number 1, 3 times sinus, and we'll substitute alpha by 90 degrees minus 2 theta, and it will be equal to 7 times sinus theta. Okay, so here we have the trigonometric identity that states that sinus 90 degrees minus x is equal to cosine x. We'll use this trigonometric identity in order to find out the value of sinus 90 degrees minus 2 theta. According to this trigonometric identity, the value of sinus 90 degrees minus 2 theta is equal to cosine 2 theta. That is to say, we can substitute sinus 90 degrees minus 2 theta in equation number 1 by cosine 2 theta. So we'll do it now, and we will get that according to equation number 1, three times, and we'll substitute sinus 90 degrees minus 2 theta by cosine 2 theta, so it is 3 times cosine 2 theta is equal to 7 times sinus theta. So I will copy equation number 1 in the new page. According to equation number 1, we found out that three times cosine 2 theta is equal to 7 times sinus theta. And we also have a trigonometric identity for cosine 2 theta. Actually, according to the following trigonometric identity, the value of cosine 2 theta is equal to 1 minus 2 times sine square theta. So we will substitute cosine 2 theta in equation number 1 by 1 minus 2 sine square theta. We'll do it now, and we'll get that 3 times cosine 2 theta, and cosine 2 theta according to this trigonometric identity is equal to 1 minus 2 times sine square theta, and it equals to 7 times sinus theta. So here 3 times 1 is 3, and 3 times minus 2 sine square theta is minus 6 times sine square theta, that equals to 7 times sine theta. Here we will add to this equation number 1, 6 times sine square theta, and we will subtract 3, and we will get that according to equation number 1, 6 times sine square theta plus 7 times sine theta minus 3 is equal to 0. Actually, equation number 1 is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general quadratic equation, a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we will find out the value of x by using the following special formula for x. Actually, x equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. And in our specific quadratic equation, we know that the coefficient a equals to 6, the coefficient b equals to 7, and the coefficient c equals to minus 3. And the variable that we are looking for in our specific quadratic equation is sinus theta. So x equals to sinus theta. So what is left now to do is to put the data inside the formula for x, and we will find out the value of the values of sinus theta. Okay, so we'll do it now, and we'll get that x is sinus theta. So sinus theta equals to minus b, and b is equal to 7, so minus b is minus 7, plus minus square root of b squared. B is 7, so b squared is 7 squared. 7 squared is 49. Minus 4 times a is 6, times c is minus 3. All divided by 2a. 2 times a, and a is 6, so it is 2 times 6. So sinus theta equals to minus 7 plus minus square root of 49, and minus 6, minus 4 times 6 is minus 24, and minus 24 times minus 3 is plus 72. Okay, so in the brackets we have 49 plus 72 divided by 2 times 6, that is actually 12. So in conclusion, we found out that sinus theta is equal to minus 7 plus minus square root of 49 plus 72 is 121, divided by 12. And the square root of 121 is 11. So I write it down. So we got that sinus theta is equal to minus 7 plus minus, and the square root of 121 is 11 divided by 12. So we will have two solutions that are possible for sinus theta. The first solution for sinus theta is that sinus theta will be equal to minus 7 minus 11 over 12, and the second solution for sinus theta is that sinus theta equals to minus 7 plus 11 over 12. So we'll focus on the first solution. The first solution is sinus theta equals to minus 7 minus 11 is minus 18. So sinus theta equals to minus 18 over 12, and minus 18 over 12 is minus 1.5. So we found out that sinus theta is equal to minus 1.5. But because of the fact that the sinus can receive values that are between between minus 1 and 1, that are smaller or equal to 1 and that are greater or equal to minus 1, and minus 1.5 is less than minus 1, therefore minus 1.5 exceeds the range of the values that sinus theta can receive. Therefore this answer is incorrect answer, because sinus theta can never be equal to minus 1.5, because the range of values that sinus theta can receive is between 1 to minus 1. And minus 1.5 is less than minus 1. Therefore, sinus theta can never be equal to minus 1.5. So this solution is incorrect solution. So we cancel this solution, and we left only with the solution that sinus theta equals to minus 7 plus 11 over 12. So sinus theta equals to minus 7 plus 11 is 4. It is 4 over 12. Here we will divide both the numerator and the denominator on this side of the equation by 4. 4 over 4 is 1, and 12 over 4 is 3. So in conclusion, we found out that sinus theta equals to 1 over 3. Okay, sinus theta equals to 1 over 3. In the next step, we'll focus on triangle ADE. So I will copy triangle ADE in a new page, and we will analyze triangle ADE. In triangle ADE, we know that AD is equal to, actually it is triangle ABE, we will focus on triangle ABE. We'll focus on triangle ABE. And in triangle ABE, it is given us in the question that AB is equal to AE. Here, we know that AB is equal to AE. And because of the fact that AB equals to AE, we will conclude that triangle ABE is an isosceles triangle. I repeat again, because of the fact that side AB is equal to side AE, we will conclude from it that triangle ABE, this triangle is an isosceles triangle, and the base of the isosceles triangle, triangle ABE, is BE. So BE is the base, and if AM is the height to the base, because of the fact that it creates 90 degrees with the base BE. Okay, so you write it down. AM is the height to the base, BE. Line segment AM is the height to the base BE. Okay? And we have rule number 1. According to rule number 1, the height to the base in an isosceles triangle bisects the base. I'll read rule number 1 again. According to rule number 1, the height to the base in an isosceles triangle bisects the base. So according to rule number 1, the height AM to the base BE in triangle, the isosceles triangle ABE bisects the base. That is to say, BM will be equal to ME, and we also know that AB equals to AE. So according to rule number 1, BM equals to ME because of the fact that AM bisects the base BE. That is to say, it divides it to two equal parts. It means that PM will be equal to ME. Okay, so I will write it down. According to rule number 1, BM equals to ME. Okay, BM equals to ME according to rule number 1. So if we know that according to rule number 1, BM is equal to ME. So if we define BM as Y, that is to say BM equals to Y according to our definition, Here we write down that BM equals to Y. Then from this equation, Y equals to BM equals to ME, we will conclude that ME is also equals to Y. ME equals to Y. So actually we can see from this drawing that from one side BM or BE, here BE is equal to BM plus ME. So BE is equal to BM plus ME. From one side, but BM equals to Y and ME is also equal to Y, so in conclusion we found out that BE equals to Y plus Y, that is 2Y. So from one side BE is equal to 2Y, but from the other side, you can see from the drawing here that BE is equal to BD plus DE. I will write it down. From the other side, BE is equal to BD plus DE. But BD is equal to 4 units and DE equals to 7 units. So in conclusion, B equals to 3 plus 7, 10 units. So we found out that from one side, BE equals to 10 units. But from the other side, we have already found out that BE equals to 2Y. So from this equation, 2Y equals to BE equals to 10, we will conclude that 2Y equals to 10. Okay, 2Y equals to 10. So I found out that 2Y equals to 10. Here we will divide this equation by 2 and we will get that Y equals to 5. Y equals to 5. That is to say, BM is equal to 5, so, and Y equals to 5, so BM is also equals to 5, and we also know that ME equals to 5. ME equals to Y, and Y equals to 5, so ME will be also equal to 5. ME equals to 5. So we can write here that BM equals to 5 units. We already found out that BM equals to 5 units. And ME is also equal to 5 units. ME is also equal to 5 units. Okay? So in the next step, we will prove that the right triangle ABM is congruent to the right triangle AME. Okay? I will write it down. We will prove that the right triangle ABM congruent to the right triangle AME. So why those two triangles can go into each other? First of all, it is given us in the question that AB equals to AE. AB equals to AE. It is given us in the question. And we just right now found out that BM equals to ME equals to 5 units. And we also know that AM equals to itself. AM equals to AM is a common side that belongs to both triangles. AM equals to AM is a common side that belongs to both triangles. So we actually proved that the right triangle, triangle ABM, congruent. This is the side of congruent to the right triangle, triangle AME, according to side rule. We actually proved that all the sides of the right triangle, triangle ABM can go into all the sides of the right triangle, triangle ABM. Therefore, those two triangles can go into each other according to side rule. And from the fact that those two triangles can go into each other, we will conclude that angle BAM, angle BAM is equal to angle MAE. And those two angles are equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. Those two triangles can go into each other, therefore the corresponding angles, that is to say angle BAM and angle MAE, will be equal to each other. So if we define angle BAM as Z, angle BAM is equal to Z according to our definition. So we can write down that angle BAM equals to Z. Then from this equation, Z equals to angle BAM equals to angle MAE, we will conclude that angle MAE equals to Z. So we actually know that angle BAM equals to Z and angle MAE is equal to Z. But what is the value of angle BAE? The value of angle BAE, from one side, angle BAE is equal to theta plus alpha. Again, angle BAE from one side it is equal to theta plus alpha. But from the other side, angle BAE is equal to angle BAM plus angle MAE. So we actually found out that from one side angle BAE equals to theta plus alpha, and from the other side angle BAE equals to angle BAM plus angle MAE. So from this equation we'll conclude that angle BAM plus angle MAE is equal to theta plus alpha, but we have already found out that angle BAM equals to y equals to z according to our definition, and angle MAE is also equals to z. That is to say, angle MAE plus angle BAM equals to 2z. Okay, so from this equation we will conclude that 2z equals to theta plus alpha, we will divide this equation by 2 and we will get that angle z is equal to theta plus alpha over 2. But angle z equals to angle BAM, so therefore we can conclude from it that angle BAM is equal to theta plus alpha over 2. And from the fact that angle MAE is also equal to z, we will conclude that angle MAE is also equal to theta plus alpha over 2. Okay, so here we can write down in the drawing that angle BAM, this angle is equal to theta plus alpha over 2. And angle MAE is also equals to theta plus alpha over 2. So this angle is equal to theta plus alpha over 2. Okay, so in the next step we will focus on the right triangle MAE. So we copy triangle MAE in a new page and we will analyze triangle MAE. So we have triangle MAE. That is right triangle. And we have already found out that angle MAE is equal to theta plus alpha over 2, so I will write it down. And side ME of the right triangle, MAE, is equal to 5 units according to the drawing. ME equals to 5 units. So this is the right triangle MAE. We will define side AM as 8. So here AM is equal to 8 according to our definition. So we can write here that AM equals to H. So in the right triangle MAE, we can write down that according to equation number 1, tangents theta plus alpha over 2 is equal to ME over AM. Tangent theta plus alpha over 2 equals to ME over AM. But we have already found out that ME equals to 5 units and AM equals to H according to our definition. So in conclusion, according to equation number 1, we found out that tangents theta plus alpha over 2 is equal to 5 over H. I will repeat again, according to equation number 1, in triangle AME, the right triangle MAE, tangents theta plus alpha over 2 equals to 5 over H. In the next step, we'll focus on the right triangle AMC. So I will copy the right triangle AMC in a new page, and we will analyze triangle AMC. What is the value of angle MAC? From the drawing, it is very easy to see that the value of angle MAC, it is actually equals to theta plus alpha over 2 plus theta. It equals to theta plus alpha over 2 plus theta. I repeat again, the value of angle MAC, it is actually equals to theta plus alpha over 2 plus theta. And what is the value of side MC? MC is equal to ME plus EC. MC, from the drawing you can see that MC equals to ME plus EC. Okay? I will repeat again. MC is equals to ME plus EC, but ME equals to 5 units and EC equals to X. So in conclusion, we found out that MC is equal to 5 plus X, I repeat again, MC equals to 5 plus X, and according to our definition, AM equals to H. and we found out that angle MAC equals to theta plus alpha over 2 plus theta. We'll find out the missing angle, angle ACM. We know that the sum of the angles in any triangle is equal to 180 degrees, and especially in triangle AMC, the sum of its angles must be equal to 180 degrees. That is to say, angle MAC, this angle, plus this angle that is equal to 90 degrees, plus the missing angle that is actually the angle that we are looking for, angle MCA. In total, the sum of those two angles must be equal to 180 degrees. So here we'll subtract 90 degrees from this equation, and we'll get that angle MAC plus angle A plus angle ACM will be equal to 180 degrees minus 90 degrees is 90 degrees. So we will subtract angle MAC from this equation, and we will get that the angle that we are looking for, that is actually angle ACM, is equal to angle MAC minus 90 degrees. So angle ACM, the angle that we are looking for, is equal to angle MAC, and angle MAC is equal to theta plus alpha over 2 is equal to theta plus alpha over 2 plus theta minus 90 degrees. But we have already found out that actually 90 degrees, here angle BAC equals to 90 degrees from one side, but it is also equals to 2 theta plus alpha. So we conclude from it that, I write it down here. We found out that angle ACM is equal to theta plus alpha over 2 plus theta minus 90 degrees, but from one side angle BAC is equal to 90 degrees, and from the other side angle BAC, this angle is equal to theta plus alpha plus theta, that is to say it equals to 2 theta plus alpha. So from this equation, 2 theta plus alpha equals to angle BAC equals to 90 degrees. We conclude that 90 degrees is equal to 2 theta plus alpha. Therefore, we can substitute 90 degrees in this equation by 2 theta plus alpha. We'll do it now and we'll get that angle ACM, the angle that we are looking for, is equal to theta plus alpha over 2 plus theta minus 90 degrees, and 90 degrees it equals to 2 theta plus alpha. So here we will open the brackets on this side of the equation and we'll get that angle ACM, the angle that we are looking for, is equal to theta plus alpha over 2 plus theta minus 2 theta minus alpha. Here 2 theta minus theta is minus theta. So angle ACM is equal to theta plus alpha over 2 minus theta so here actually we found out that angle BAC is equal to 90 degrees, that is to say angle BAC equals to 2 theta plus alpha, and we substituted 90 degrees by 2 theta plus alpha, and we got that angle ACM equals to again we have here angle this angle ACM is equal to 180 degrees minus this angle minus 90 degrees. Angle MAC plus 90 degrees plus angle ACM equals to 180 degrees. So angle MAC plus angle ACM equals to 180 degrees minus 90 degrees is 90 degrees. We subtracted angle MAC from this equation and we got that angle ACM, the angle that we are looking for, is equal to 90 degrees minus, this is 90 degrees minus angle MAC actually found out that angle ACM is equal to 90 degrees minus angle MAC. So angle ACM is equal to 90 degrees minus angle MAC, that is actually equals to theta plus alpha over 2 plus theta. And we know that angle ACM is equal to 2 theta plus alpha minus theta plus alpha over 2 plus theta, and alpha equals to 90 degrees minus theta, so angle ACM is equal to 2 theta plus alpha is 90 degrees minus 2 theta, so here angle ACM equals to 90 degrees minus theta plus alpha over 2 plus theta, and here 90 degrees is 2 theta plus alpha, so it is 2 theta plus alpha minus theta plus alpha over 2 plus theta, so it is 2 theta plus alpha, 2 theta plus alpha minus theta plus alpha over 2. So here 2 theta minus theta is theta, so angle ACM equals to theta plus alpha minus theta plus alpha over 2, and theta plus alpha minus theta plus alpha over 2 is equal to angle ACM is equal to theta plus alpha over 2. So we found out that angle ACM equals to theta plus alpha over 2. So we copy triangle ACM in the new page, and we will put the value of angle ACM inside the triangle. Angle ACM equals to theta plus alpha over 2. This angle equals to 90 degrees, and AM equals to H. So here tangents theta plus alpha over 2 moving to equation number 2, tangents theta plus alpha over 2 is equal to AM over MC, but AM equals to H and MC equals to 5 plus X. So according to equation number 2, we found out that tangents theta plus alpha over 2 is equal to H over 5 plus X. This is according to equation number 2. And according to equation number 1, we have already found out that tangent theta plus alpha over 2 is equal to 5 over h. So here we will combine equation number 1 with equation number 2 and we will create equation number 3. So according to equation number 3, tangent theta plus alpha over 2 will be equal to h over 5 plus x according to equation number 2, while according to equation number 1 it equals to 5 over h. So equation number 3 is the combination of equation number 1 with equation number 2. Then we find out the value of theta plus alpha over 2. So the value of theta plus alpha over 2 will be equal to theta plus alpha, and alpha equals to 90 degrees minus 2 theta, so we substitute alpha by 90 degrees minus 2 theta over 2. Here theta minus 2 theta is minus theta, so it is 90 degrees minus theta over 2. 90 degrees over 2 is 45 degrees minus theta over 2. So here, in conclusion, we found out that theta plus alpha over 2 is equal to 45 degrees minus theta over 2. And we also know that if alpha equals to beta, then tangent alpha equals to tangent beta. That is to say, tangent theta plus alpha over 2 will be equal to tangent 45 degrees minus theta over 2. And here we have a trigonometric identity that states that tangent x minus y is equal to tangent x minus tangent y over 1 plus tangent x times tangent y. We will use this trigonometric identity in order to find out the value of tangent 45 degrees minus theta over 2. So the value of tangent 45 degrees minus theta over 2 will be equal, according to this trigonometric identity, to tangent 45 degrees minus tangent theta over 2 over 1 plus tangent 45 degrees times tangent theta over 2. So it is equal to tangent 45 degrees is 1 minus theta minus tangent theta over 2 over 1 plus tangent 45 degrees is 1 times tangent theta over 2. So in conclusion, we actually found out that tangent theta plus alpha over 2 it is actually equals to 1 minus tangent theta over 2 over 1 plus tangent theta over 2. Okay. And in order to find out the value of tangent theta plus alpha over 2, the only thing that we need to do is to find out the value of tangent theta over 2. And we have trigonometric identity from tangent theta over 2. The value of tangent, the value of tangent theta over 2 is equal to sinus theta over 1 plus cosine theta. And we have already found out that sinus theta is equal to 1 over 3. And we have the trigonometric identity that states that sinus square theta plus cosine square theta equals to 1. We will subtract sinus square theta from the trigonometric identity, and we get that cosine square theta equals to 1 minus sine square theta. We'll take a root out of this equation, and we'll get that cosine theta is equal to the square root of 1 minus sinus square theta. So if sinus theta equals to 1 over 3, then sinus square theta will be equal to 1 over 9. So we'll put it inside the equation, and we'll get that cosine theta is equal to the square root of 1 minus 1 over 9. 1 minus 1 over 9 is 8 over 9, and the square root of 8 is 2 times square root of 2, and the square root of 9 is 3. So in conclusion, we found out that cosine theta is equal to 2 times square root of 2 over 3, and we have already found out that sinus theta is equal to 1 over 3. So we put the value of sinus theta and cosine theta inside the trigonometric identity of tangent theta over 2. We will get that tangent theta over 2 is equal to sinus theta is 1 over 3 over 1 plus cosine theta, and we have already found out that cosine theta equals to 2 times square root of 2 over 3. So it equals to 1 over 3. Here we'll multiply 1 by 3, and then we'll divide it by 3 in order to have a common factor with this expression, and we'll get that 3 times 2 times square root of 2 over 3 equals to tangent theta over 2. Here we have 3 in the numerator and 3 in the denominator, so 3 will get cancelled, and we left with only 1 over 3 plus 2 times square root of 2. So in conclusion, we actually found out that tangent theta over 2 here tangent theta over 2 is equal to 1 over 3 plus 2 times square root of 2. So here we will simplify this expression. We take this expression 1 over 3 plus 2 times square root of 2. We multiply this expression by 3 minus 2 times square root of 2, and then we will divide it by 3 minus 2 times square root of 2. So it is 1 over 3 plus 2 times square root of 2. We will multiply this expression by 3 minus 2 times square root of 2, and then we will divide it by 3 minus 2 times square root of 2. So here we have 3 minus 2 times square root of 2 in the numerator. In the denominator we have expression 3 plus 2 times square root of 2 times 3 minus 2 times square root of 2. It is very similar to the algebraic identity that states that a plus b times a minus b equals to a squared minus b squared. So here a is 3 and a squared is 3 squared, that is 9. And b is 2 times square root of 2, so b squared is 2 times square root of 2 squared, that is actually 8. So it is minus 8. So in conclusion, we found out that this expression equals to 3 minus 2 times square root of 2. That is to say, we found out that tangent theta over 2 is equals to 3 minus 2 times square root of 2. Now we can put the value of tangent theta over 2 in the equation for tangent theta plus alpha over 2. We have already found out that tangent theta plus alpha over 2 is equal to 1 minus tangent theta over 2 over 1 plus tangent theta over 2. So it equals to 1 minus tangent theta over 2 is 3 minus 2 times square root of 2 over 1 plus tangent theta over 2, that is actually equals to 3 minus 2 times square root of 2. That equals to 1 minus 3 is minus 2, minus and minus is plus, so it is plus 2 times square root of 2 over 1 plus 3 is 4, minus 2 times square root of 2. So here we have 2 times square root of 2 minus 2 over 4 minus 2 times square root of 2 equals to, here from the numerator we will take 2 as a common factor. So inside the brackets we will have square root of 2 minus 1. And from the denominator we will take a common factor of 2 times square root of 2. We will take 2 times square root of 2 as a common factor. And inside the brackets we will have square root of 2 minus 1. We have square root of 2 minus 1 in the numerator and square root of 2 minus 1 in the denominator. So square root of 2 minus 1 will get cancelled. We have 2 in the numerator and 2 in the denominator. So 2 over 2 is 1, so 2 will get cancelled. And we left only with 1 over square root of 2. So in conclusion, we actually found out that tangent theta plus alpha over 2 is equal to 1 over square root of 3. I repeat again, we actually found out that the value of tangent theta plus alpha over 2 is equal to 1 over square root of 3. And according to equation number 3, we have already found out that tangent theta plus alpha over 2 is equal to h over 5 plus x, and it is also equals to 5 over h. And we just right now found out that tangent theta plus alpha over 2 equals to 1 over square root of 2. So from this long equation, equation number 3, we will derive that h over 5 is equal to 1 over square root of 2. H over 5 is equal to 1 over square root of 2. We will cross multiply this equation and we will get that h equals to 5 times square root of 2 h equals to 5 over h is equal to 1 over square root of 2. We cross multiply this equation and we found out that h equals to 5 times square root of 2. We will derive the second equation from this long equation. We will derive that h over 5 plus x is also equals to 1 over 2. Here h over 5 plus x is also equals to 1 over square root of 2. We have already found out that h equals to 5 times square root of 2, so we substitute h by 5 times square root of 2 over 5 plus x. It equals to 1 over square root of 2. Here we will cross multiply this equation and we will find out that 5 times square root of 2 times square root of 2 is equal to 5 plus x. Square root of 2 times square root of 2 is 2, and 2 times 5 is 10. So in conclusion, we found out that 10 equals to 5 plus x. Here we will subtract 5 from this equation, and we found out that x equals to 5 units. So x, that is also equals to CE, is equal to 5 units. So the answer to the question is that x is equal to 5 units. X that equals to CE is equal to 5 units. Okay, thank you very much.